Hey, Mr. Ruth here. Going to go over some of these Kognity questions that some of you, I think, maybe having a little trouble with. So let's start with number one. Okay, so in this distance, they give us some information at the top. We got meters and seconds are our units. And we have two lines written in vector format. So we've got r equals this position vector plus t times this direction vector, and r equals this position vector times t plus t times this direction vector, where t represents time. And we're asked to find the minimum distance between the two objects. So we have to remember our three-dimensional distance formula in order to do this problem. Our three-dimensional distance formula is this. It's x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. All right, and so what we're trying to do is we're trying to minimize this. So as soon as you hear see the word minimum distance, some alarm bells should be going off on some of you. You could try to solve this using calculus and using the first derivative. However, that is not the smartest way to try to solve this. The smartest way to try to solve this is eventually to get a formula for distance and then GDC it and look for the minimum, which you can, of course, do on your TI-84 or using Desmos just by hunting for the minimum. So here's what we're going to do. We're going to try to find, using this information, the two lines, we're going to try to find an equation. We're going to try to solve for D. We're going to graph this thing, and we're going to use the GDC to find the minimum. So that's our strategy. So the question is, how do we figure out what goes into these spots? Let's look at the two lines. So in the first line, I've got R equals, and I'm just copying down what I have above. All right. Now, I'm adding vectors here. So I could rewrite this as 3 plus t times -1. Or, of course, which is just 3 minus t. Then 2 plus -2t, -6 plus 3t. Right, this is the first line, which I'll call R1. The second line, I can do the same method. I'm not going to rewrite it, but using the same method, -2 plus t times 1, 7 plus -3t, 6 plus -2t. All right, so I have my two lines written kind of just as vectors. Now, the vectors have variables in them, but these are still just the x coordinates. These are the y coordinates. These are the z coordinates. This is line 1, so this is x1, y1, z1. This is r2, so this is x2, y2, z2. So I have the variables I need. I have everything I need to plug into the distance formula over here, and then I'll have it all expressed in one variable, which is t. So let's do the substitution. Substitution gets a little funky, but work through it. It's not so bad. All right, so x1 minus x2 squared. So I have 3 minus t minus -2 plus t, and then this whole thing is going to be squared, plus 2 minus 2t minus 7 minus 3t, and this whole quantity is squared, plus -6 plus 3t. Again, this is z1 minus z2, minus 6 minus 2t. I'm using the parentheses to make sure I'm going to remember to distribute the negative through. And this is all squared. So obviously a lot of work to do, but it's all simple algebra. Let's change the color for the next line. So what do I have here? I get 3 minus a -2. So that's 5. And -t minus 2t. I get 2 minus 7, that's -5. -2 minus a -3t, that's -2t plus 3t, so that's t. -6 minus a -6, -12. 3t minus a -2t is plus 5t. All right, so, a lot of work here. Now I've got to FOIL these things out. Yeah, this isn't the funnest thing. But you know what? I realized I could type this in to my calculator. If I'm just doing GDC, there's no reason I have to keep going. My calculator can handle that. So I'm going over to Desmos. And I'm going to make the screen smaller so I can see everything that's on it. But I can type this in. Now, of course, Desmos can't handle t, but it can handle x and y. So square root of 5 minus 2x squared plus negative 5 plus t, the quantity squared, oops, not t, x, plus negative 12 plus 5x, the quantity squared. And I get this equation. So this, and I'm looking for what? I'm trying to minimize the distance, trying to find the minimum distance between the two objects. So distance is the x or the y here. Distance is definitely going to be the y variable. It's out in front, just like y is out in front in our equation here. D is out in front in our equation. So I'm looking for the minimum distance, which is the y value. And I can see here by just clicking on the point in Desmos that the minimum distance is 2.55 meters. Let's just go back and check and make sure we've answered everything in the question. Find the minimum distance between the two objects. Give your answer as a decimal, rounded to 3 significant figures. There we go. Hope that was helpful.